Welcome to the lecture number 1 of unit number 6, applications of partial differential equation. In previous unit, we have seen the forms of partial differential equation and what are its various activities. So remember, in wave equation on both the sides, you have capital X. So d2x by dx square. Now both the testing. So d square plus b square is equal to 0. 0 can be written as sine of n pi because if we put sine pi, sine 2 pi, sine 3 pi, all values are 0. So instead of 0, we can write it as sine n pi. Now equating both the sides, sine get cancelled, remaining is here is equal to n pi. Means b is equal to n pi by n. So this is the value which we opted for b. Substituting that value here, pi becomes c2 into sine n pi x by
The maximum
Sir, class start है ना?
Hello.
Morning, sir.
Hello.
Good morning, sir.
Hello, anybody?
Hello, good morning, sir.
Hello. Are you getting my voice? Arshia,
Morning, sir.
good morning. Good morning. ఎవరు సపోర్ట్ చేశారు? మీరు ఎవరు రాలేదని నేను చూస్తున్నాను.
Yes, sir.
What about you?
Only 2 members.
Only 2 members here. And level 20 up to completed. Hello.
Hello.
Up to completed. What about last class?
Sir, slow voice is sir.
Oh, yes. Now it is okay.
Okay, sir.
Yes.
కొంచెం స్లో వస్తుంది వాయిస్.
Hello. Hello.
Hello.
Yes.
Sir, are you taking class, sir, today? There is no student, sir.
Hello.
There is no students, sir. Only 2 members are there.
Yes. Yes. Can I continue class?
మీ ఇష్టం, sir. Because there is no students, sir.
Yes. So we have any discuss any topic that you want? Hello.
Okay, sir. Okay. The another member. Where is another member?
ఎక్కడో ఆన్ చేస్తున్నారు ఎక్కడో వెళ్తున్నారు. Okay. Any important theorems to discuss? Hello.
No, hello, sir.
Very
Sir, say
important.
important.
Previous papers ఉన్నాయండి దగ్గర.
No, sir.
Previous paper అంటే better. Okay. లాస్ట్ క్లాస్ ఇక్కడ వరకు అయింది తొందరగా. మెజరబుల్ ఫంక్షన్స్ అయిపోయిందా? హలో, మెజరబుల్ ఫంక్షన్స్. హలో, పేజ్ నెంబర్ 35. Arshia. Hello.
Hello, sir. Hello. Seeing, sir. Seeing.
Page number 38. Page number 35.
35 measurable function.
Measure functions, measurable functions.
Yes, sir.
Just,
sir, important theorems అంటే చెప్పండి సార్.
Important theorems ఏమున్నాయి నాకు? Important theorems. Measure theory. మీకు నోట్స్ పంపించాను, మీకు ఒకటి మెజర్ థియరీ
ఇన్ గ్రూప్ సార్.
గ్రూప్ లో పెట్టానా? మెజర్ థియరీ ఒక నోట్స్ ఉంటుంది.
ఏమో సార్, నేను గ్రూప్ లో లేదు. ఆ గ్రూప్ 2020 గ్రూప్.
మెజర్ థియరీ
పంపారు సార్ పీడిఎఫ్.
పంపాను పీడిఎఫ్.
పంపారు.
మెజరబుల్ సెట్స్ అయిపోయింది. మెజరబుల్ ఫంక్షన్స్ measurable functions. So measurable functions are this definition is extended to real valued function means it is mapping to the what is that mapping to the minus infinite to or infinite, and any measurable set is said to be measurable function. Any real valued function f, this is f, just write down definition. Any real valued function, any an extended real valued function f defined on a measurable set E is said to be measurable function if the set any element belongs to the E such that what is the this big number alpha is a f of x greater than alpha is measurable for every extended real number alpha. This is the definition of measurable functions. Any function which is defined on measurable set is said to be measurable function. We have some set or there exists a set which is what is that x belongs to the set of all elements which are f of x greater than alpha is measurable extended to real value number. Okay now, so every extended real valued function for each real number alpha the set x is a measurable set. For each real value alpha the set is x belongs to f of x greater than or equals is also measurable. Okay now, and for each real number less than alpha is also measurable. Less than or equal to alpha is also measurable. These are the four very important the properties to measurable of any function. And observe here already first is definition. The first property is if you want to say any set is measurable, which is defined on measurable set, measurable function, satisfy there exists a set in that set containing the elements which are belongs to E and satisfying the condition f of x greater than alpha. That is a measurable set. No need to prove. And observe here, proof. Suppose that f be an extended real valued function defined on measurable set E, and first to second. What is that? If any function is measurable, if the set is measurable, then prove that less than or greater than or equal to, greater than or equal to. And what is that? Given that what the set is x belongs to E such that write down here. Now we prove that first implies to second. Roughly write down. First implies to second. First
Sir,
implies
in
to second.
textbook, where is it, sir?
Just wait, textbook. Number 35.
35.
After 35, 36 page number.
Okay, sir.
That is measurable functions. You are not clear. Okay, now. And here
Sorry.
this is enough. Generally, measurable function definition. That is, the definition is any set satisfying the condition f of x is greater than alpha. That is the set is a measurable set. Then that function is called the measurable function on that set. Now we prove that a, b, c, d here. Okay, now a, b, c, d here. A means what is that? First we given definition only.
F is,
A, B, C.
F.
It is 36 page number.
yes, sir. F is measurable function.
If it measurable means what is that? The set x belongs to such that f of x greater
F
than
of x
alpha.
greater than alpha.
Just write down here. Now we prove that A tends to A implies B. Now we prove that A implies B. First one. A implies B means what is the meaning? If f is measurable function, f is measurable function, then we prove that the set x belongs to E such that f of x greater than or equal to alpha is also measurable set. Is also measurable.
Okay, sir.
Okay. Next write down. F is measurable function, which implies that is f is measurable function, which implies the set same
X belongs to E.
E such that f of x greater than
F
alpha
of-
is measurable set. Measurable set. Measurable set.
Yes, sir.
Now we consider x belongs same statement right now. X belongs to E, f of x greater than or equals to alpha. Greater than or equals to alpha. Alpha equal to intersection. Intersection n equal to 1 to infinity. Intersection 1 to infinity. 1 to infinity. X belongs to E, f of x greater than alpha minus 1 by n, we can write. Alpha minus 1 by n. And observe here alpha minus 1 by n, intersection of, what is the intersection? It will give n equal to 1. Alpha minus 1 by n, intersection. Alpha minus 1 by 2, intersection. Alpha minus 1 by 3, intersection. What is that we can write? Suppose n goes to infinity. What is that? F of x greater than or equal to. Okay, now alpha minus. Suppose what is that? A less than B. A less than B means A less than or equal to, you can write B minus 1, B minus something. Correct now? Suppose 2 less than 3. Just write down roughly 2 less than 3. 2 less than 3. We can
Excuse
write.
me, sir. Sir, screen కనిపిస్తలేదు, sir.
కనిపిస్తలేదు. Just wait. Now.
Yes, sir.
So roughly write down. We can write any element. Suppose 2 less than 3. We can write 2 less than or equal to 3 minus 1. Clear? Simple. Hello?
Okay, sir.
Therefore, observe here, we can write intersection of some f of x greater than alpha minus 1 by n. This alpha minus 1 by n is a alpha 1, another alpha 1. So alpha 1 equals to alpha 1. Therefore, what is that? We know that. Write down. We know that. Write down. But we have x belongs to E such that f of x greater than alpha minus 1 by n is a measurable set for all n. But we have, write down, x belongs to E such that f of x greater than alpha minus 1 by n is measurable set for every n. And we have a theorem in measure theory. What is that? What is that? Measurable set on measurable set. And we have next, intersection of countable collection of measurable set is a measurable. Write down. Intersection of
N equals to 1 to infinity.
The intersection of countable collection of measurable sets is a measurable therefore
Intersection N equals to 1 to infinity.
therefore intersection 1 to infinity is a measurable set.
Okay.
Is a measurable set. Intersection equal to by this one. What is that? By this one, this is equal to, we can write greater than or equals. Greater than or equals. Therefore, hence x belongs to the given set. F of x is greater than or equals
And
to
equals to alpha.
alpha is a measurable set.
Measurable set.
Okay,
In alpha plus star. Yes, sir.
alpha. Both are same. So this one. Okay, no? Next. Second implies first. Second implies first.
For alpha,
Write down. Let suppose x belongs to it. Alpha. Second implies first one. Given information is second one. By using this one,
second, yes.
prove that the first one only.
First one.
Consider x belongs to E such that f of x greater than or equals to alpha is a measurable set.
Yes, sir.
Measurable set. Then we prove that
It's
f of x is a measurable function. Then we prove that f of x is measurable function. F of x is measurable function, or x belongs to E, the set x belongs to E such that f of x greater than alpha is measurable set. Measurable function of either, or x belongs to the set f of x greater than alpha is measurable set. But this set, okay, na? And next, this set can be written as countable union of the set. Write down. This set can be written as countable union of the sets Grand. Second one, X belongs countable union of X belongs to E such that f of X greater than or equals to alpha plus 1 by n. Alpha plus 1 by n. Suppose 3 greater than 2. Equal రాయాలంటే ఏం చేస్తాము? 3 greater than 2. Equal రాయాలంటే plus 1 యాడ్ చేస్తాం లెఫ్ట్ సైడ్. చిన్న లాజిక్ ఇది. f of X greater than or equals to రాయాలంటే ఏం రాస్తాము? Suppose 2 greater than 3. What is that? 3 greater than 2 ఉంటుంది. లెఫ్ట్ సైడ్ ఏం చేయాలి? యాడ్ చేయాలి. ఒకవేళ లెస్ దెన్ ఉంటే మైనస్ చేస్తాం. ఓకేనా? సో అబ్జర్వ్ హియర్ can be written as union of countable union of X belongs to E such that f of X greater than or equals to alpha plus 1 by n. 1 by n.
Greater than means adding.
Greater than or equal to. Suppose ఇక్కడ సో అబ్జర్వ్ హియర్ 3 greater than 2 ఉన్నది అక్కడ. greater than or equal to రాయాలి.
ఓకే సార్.
r equal to means 3 రావాలి కదా. 3 రావాలి. లెఫ్ట్ సైడ్ ఏం చేస్తాము? యాడ్ చేస్తాము. అంటే కన్ఫ్యూజన్ హియర్ లెఫ్ట్ సైడ్. ఓకే సారీ రైట్ సైడ్ యాడ్ చేస్తాము. లెఫ్ట్ సైడ్ ఏం చేస్తాము? మైనస్ చేస్తాము. ఓకేనా?
ఓకే సార్. ఓకే.
Therefore since X belongs to E, f of X greater than or equals to alpha plus 1 by n. Alpha plus 1 by, we can consider another alpha 1 is a measurable for all n. For all n. Measurable for all n. Measurable for all n. Measurable for all n. After that, is a measurable for every n. And we know that next, and we know that countable union of measurable sets is again a measurable. Write down. Countable union of countable union of measurable set is a measurable. Therefore, n equal to 1 to infinity union is and countable union n equal to 1 to infinity X belongs to E, f of X greater than or equals to alpha plus 1 by n is measurable. Therefore X, the set, the X belongs to E such that f of X greater than alpha is measurable. Is measurable. This set is measurable ante vastundi f of X is measurable function. Finally, f of X is measurable function. Measurable function. Okay na?
Okay sir.
Next, first to fourth. మనం ఆల్రెడీ మెజరబుల్ సెట్స్ ఇవన్నీ ప్రూవ్ చేస్తాము. కౌంటబుల్ యూనియన్ ఆఫ్ మెజరబుల్ సెట్ ఇస్ ఏ మెజరబుల్, కౌంటబుల్ ఇంటర్సెక్షన్ ఆఫ్ మెజరబుల్ సెట్ ఇస్ ఏ మెజరబుల్, కాంప్లిమెంటేషన్ ఆఫ్ మెజరబుల్ సెట్ ఇస్ మెజరబుల్. ఇక్కడ కాంప్లిమెంటేషన్ తీసుకుందాం. ఓకేనా? ఫస్ట్ టు ఫోర్త్. ఫస్ట్ implies and implies. First to fourth. Consider X belongs to E, f of X greater than alpha is a measurable set. First clear examination lo ఎంత రాయాలండి? What is the given information? By using this information, we should present everything. Okay na?
Okay sir.
Consider X belongs to E, f of X greater than alpha is a measurable. Then we prove that. What is the last one? Then we prove that X belongs to E.
X belongs to E. F of X
less than or equals to alpha is a measurable set. Okay, measurable for all. Next. Input we have a statement. We have suppose A is a measurable set. A is a measurable set. Then its complement is also measurable set. Generalization. A is a measurable set. Its complement is also a measurable set. Measurable set. Measurable set. Measurable set. Therefore, E set and first set. Therefore, X belongs to E such that f of x greater than alpha is a measurable. Then its complement. Its complement. X belongs to E. F of x greater than alpha. Whole complement రాయండి ఇక్కడ. Hello.
Sir, listening.
Whole complement రాయండి. Whole complement is equals to whole complement. Any set is complement ante what is that? Any set is complement. Universal set minus that set. Correct enough? Complementation of any set. A complement equal to, complementation. Whole complement equals to, write down this one. E minus x belongs to E. Are you listening? Hello?
Listening, sir.
What is the complement? This set is complement equals to E minus x belongs to E such that f of x greater than alpha. Greater than alpha is also a measurable set.
Yes, sir.
Measurable set. That is any element f of x greater than alpha complementation ante vastundi. So less than or equals to alpha vastundi. Correct ena?
Yes, sir.
That is E minus x belongs to E such that f of x greater than alpha equals to E minus x belongs to E such that f of x greater than alpha equals to x belongs to E such that f of x less than or equals to alpha.
Two sets we have to write, sir.
Hello?
Okay. Hello, sir.
E minus x belongs to E such that f of x greater than alpha is equal to, we can
And
write
equals to
x
x belongs to E such that
such
f of x less than alpha.
less than or equals to alpha.
Okay,
Hence,
sir.
the left side is a measurable set that is equal to this one. This is also measurable. Clear?
Okay, sir.
మళ్ళీ రివర్స్ కూడా ఇక్కడ దీని కాంప్లిమెంటేషన్ తీసుకున్నాము. X belongs to f of x less than or equals to alpha complementation f of x greater than alpha. They are clearly given that this is a measurable set. Clearly, we can prove this one. Same. Now we consider x belongs to f of x greater than alpha equals to, we can write E minus x belongs to f of x less than or equals to alpha. Clearly, f of x less than or equal to alpha is a measurable. Therefore, what is the right left hand side? This is also a measurable set. Okay, now?
Okay, sir.
Complementation తీసుకుంటాడు అంతే సార్. So finally, second to third, second, third, and BC, second to B tends to C. అది పెండోల్ కండిషన్ అది కూడా ఇక్కడ కూడా కాంప్లిమెంటేషన్ వస్తుంది. We assume that for each real number alpha, just write down formally. We assume that for each real number alpha, ఇక్కడ కరెక్ట్ రాసింది నోట్స్ లో. Real number alpha x belongs to f of x greater or equals to is measurable. Now we prove that. Now we prove that. Now we prove that x belongs to f of x less than alpha is a measurable. ఖచ్చితంగా థీరం రాయాలి జనరల్ ఇక్కడ కాంప్లిమెంటేషన్ తీసుకుంటున్నాం కాబట్టి in measure theory what is that after this one write down we know that any set is measurable, its complementation is also measurable set. Any set is measurable, then its complement next we know that any set is measurable. Any set is measurable, then its complement is also measurable set.
Okay, sir.
Measurable. Okay. Next, therefore, the complement of this above set is x. We write set and x belongs to such that f of x is not equal to alpha whole complement.
Okay,
Whole
sir.
complement equals to e minus whole complement e minus ఇక్కడ రాయండి రివర్స్ రాసుకోండి e minus x belongs to e such that f of x greater than or equals to alpha
Over, sir.
alpha is a measurable set. Is a measurable set. Hence, that the set equal divide to the x belongs to such that f of x less than alpha is also a measurable. Okay, na? అంతే కాంప్లిమెంటేషన్ రివర్స్ కూడా కాంప్లిమెంట్ తీసుకోండి. క్లియరా? క్లియరా? హలో
Yes, sir. Yes, sir.
క్లియర్ చేస్తారు కాంప్లిమెంట్ తీసేసుకోండి అంతే.
Okay, sir.
Next, one important definition. Characteristic function. The characteristic function. All right. If E is any function, last round you 36 failed. 36 failed.
Second theorem, no, sir.
The definition of second theorem was
Okay, sir.
36 failed last definition.
Yes, sir. Is there?
Write down. Any set, if E is any set, then the function is mapping xi suffix c r tends to r defined by. If this function value is 1 when x belongs to E.
X belongs to E. 0 if X does not belong to E.
Okay, now. So that was the meaning of the characteristic function of E means So there exists a function defined. This function is, suppose E is a subset of R here. Any element belongs to E, then that element substitute in that function that goes to the one when X belongs to E. X does not belongs to any other than in E set, it goes to the 0. Clear?
Okay, sir.
Okay, no?
Characteristics.
Next, observe here. Theorem 2. Theorem 2. Its characteristic function is also measurable function. Characteristic function is also, just observe, just define this one. We can write by the hypothesis the theorem fixed one in unit 2 lo check చేయండి అమ్మ. Okay na? Any function
Okay,
is
sir.
greater than alpha is measurable set for. Suppose alpha greater than alpha means what is that? Alpha less than 0 or alpha in between 0 to 1 E. Alpha greater than 1 is pi. This is the function. Just define this function only. Okay na? And one more theorem. Just alpha of x equal to minus alpha. Let C be any constant function. F and G are real valued functions. Then ఇక్కడ మనకి ఏముంది? థీరం 3 ఉంది చూడండి మేడం. థీరం 3.
Let f and g be real valued measurable function, both defined on the same measurable set E,
Yes.
and C be a real number. Then f plus
అంటే
g.
addition of, so C is any constant, adding the, what is that, any constant to the measurable function. F plus C is also measurable, and multiplying by C is also measurable. F plus G is also measurable. Addition of two measurable function is a measurable. What is the meaning of this word? There is a constant multiple of any measurable function is measurable, and addition of any constant of measurable function is measurable, and addition and subtraction of and product are also measurable, and f square is also measurable. Clear?
Yes, sir.
Clear? Yes. Now, and first one. What is that? F plus C is measurable means, write down. By the definition of measurable function, write down.
Second
Let
one,
E be,
sir.
just
The
write down.
third theorem, no?
Yeah. Yes, third theorem. Just write down. Proof.
Okay, sir.
Let E be any measurable set. E be any measurable set, and the any function f is defined on E.
Any function.
Any measurable function f. No, measurable function రాయొద్దు. Let E be the any measurable set. Any f is defined on any function. F is defined on the set E. Defined on the set E. Is measurable. Is measurable. Is measurable. Is measurable. If and only if f is a measurable function. Is measurable function. Measurable function అంటే meaning ఏంటి? If and only if x belongs to the set. The set x belongs to E such that f of x greater than alpha. X belongs to the same line. Such that f of x greater than alpha is a measurable set. Measurable set. Okay na? ఇప్పుడు మ్యాటర్ మెయిన్ థీరం అబ్జర్వ్. Let C be the any constant. Let C be the any constant, and let any real number alpha belongs to R. Alpha belongs to R. We prove that f plus c of x, f plus c of x is a measurable function. Is a measurable function. Is a measurable function, which implies is a measurable function. Next round. Next, we enough to prove that. We enough to prove that. We enough to prove that.
Yes, yes, sir.
Enough to prove that the set x belongs to E such that f plus c greater than alpha is a measurable set. Is a measurable set.
F plus c into x.
Of x into x, of x function.
F plus c of
f
x.
of x greater than alpha is a measurable set. Measurable set. For this, the set x belongs to E such that f of x plus c greater than alpha equals to x belongs to the same round, f of x greater than alpha minus c. Alpha minus c. So
Sir,
observing here
once
alpha.
again say this line, sir.
Wait. What about this one? What about? Hello?
First, this the set.
The set x belongs to such that f of x plus c greater than alpha. This is equals to c at the aside this together.
Yes, sir.
X belongs to E. F of x greater than alpha minus c. Alpha minus c. Akkada put alpha minus equal to alpha 1. Alpha 1. Okay, na? Write down. For any real number alpha 1 belongs to R. For any real number, for any alpha 1 belongs to R.
Alpha belongs to R.
R, the set x belongs to E such that f of x greater than alpha 1.
X
Alpha 1.
belongs to E.
X belongs to E such that semicolon dots written parvale such that symbol.
Okay, sir.
Parvale. F of x greater than alpha 1 is measurable set. Measurable set. And the same way alpha 1 and alpha minus alpha 1 equal to alpha minus c. Alpha minus c equal to f of x greater than plus a. Hence, f plus c is a measurable function. F plus c is a measurable function. ఇప్పుడు ఆల్ఫా ఇంటూ సి ఏం చేస్తారు మీరు? సేమ్ మ్యాటర్ సేమ్ వస్తుంది మేడం. ఇక్కడ అబ్జర్వ్ చేశారా లేదు? ఆల్ఫాని సి నాట్ తీసుకెళ్తే ఇక్కడ ప్లస్ ఉంటే ఏమైంది? మైనస్ సి అయింది. ఓకేనా?
ఓకే సార్.
ఇక్కడ ఏమవుతుంది? ఆల్ఫా బై సి అవుతుంది. ఫర్ ఎనీ ఆల్ఫా 1 ఈక్వల్ టు ఆల్ఫా బై సి. దెర్ఫోర్ సేమ్ రాయండి, అక్కడ సేమ్ ప్రూఫ్ వస్తుంది.
ఓకే సార్.
ఓకేనా? కాకపోతే ఏంటంటే సి ఈజ్ గ్రేటర్ దెన్ సి, సి లెస్ దెన్ సి, అవి పాజిటివ్ అండ్ నెగిటివ్ వస్తుంది. ఓకేనా. సి ఈక్వల్ టు 0, సి ఈక్వల్ టు 0 is a zero set. What is a zero function? Is a measurable function. No need to, there is no explanation for this one. If c greater than 0, therefore x belongs to E, f of x greater than alpha by c is also a measurable set. Suppose c less than 0, observe చేస్తున్నారా?
సార్ స్క్రీన్ చూపెట్టండి సార్ స్క్రీన్ లో.
దీంట్లో ప్రూవ్ ఇవ్వలేదు కదా, ఇవ్వలేదు, దీంట్లో ఇవ్వలేదు. మన బుక్ లో అబ్జర్వ్ చేయండి.
ఎస్ సార్ yes.
ఇక్కడ ఉన్నది proposition. For any c greater than 0, cf alpha by c, and c less than 0, case 2. C less than 0 means negative. Well, in case greater than alpha by c అంటే c is negative కాబట్టి less than alpha వస్తుంది మేడం, alpha by c వస్తుంది.
ఓకే సార్.
ఓకేనా.
ఓకే సార్. ఓకే.
Alpha by c means equal to alpha 1. We clearly already proved f of x, any function is dependent on E. F of x less than alpha is also a measurable set. Therefore, c is any positive or negative or 0, any the function is measurable. So next one. Now we prove that f plus g of x. F plus g of x. F plus g of x. Is a clear and f comma g are measurable function. Now we prove that f plus g is a measurable function. Is a measurable function. That means now we prove that the set x belongs to E.
Such that f plus
F
g of
belongs.
x.
Now we prove that the set x belongs to E such that f plus g of x greater than alpha.
Condition. Okay sir.
Greater than alpha is a measurable. Is a measurable. Is a measurable. Is a measurable. Okay, na? Therefore, same x belongs to f plus g of x greater than alpha equal to same right mandi ikkada. X belongs to E such that f plus g of x greater than alpha equals to x belongs to E. F of x plus f of g of x greater than alpha. X belongs to E. F of x greater than alpha minus g of x. Alpha minus g of x. దీని తర్వాత మీ బుక్ లో ఉన్నది రాయండి మేడం, క్లియర్ ఉంది ఇక్కడ.
Okay sir.
We can write anything, but this is very clear. F of x greater than alpha minus g of x depend on if there is a rational number Rn such that same line Rn and f of x greater than alpha minus g of x. Any element, just element లో తీసుకోండి. 4 greater than 2 రాస్తాం. 4 greater than 2 అంటే అక్కడ 4 greater than 3 greater than 2 రాయొచ్చు కదా జనరలైజేషన్ లో. F of x greater than alpha minus any value. Suppose 4 greater than or 10 greater than 2 ఉంటుంది. You can write more numbers. Okay na? So we have this such what is that condition, we are satisfying any condition, this condition by which implies Rn such that f of x greater than Rn greater than alpha minus gx. Next, and we have x belongs to E, f of x greater than alpha minus gx. Alpha minus gx is equals to n equal to 1 to infinity. N equal to 1 to infinity. X belongs to E. R1, R2, R3, all are. Rn is a generalization. అంటే వీడు రేషనల్ నెంబర్ ఎందుకు తీసుకున్నాడు అంటే అబ్జర్వ్ హియర్ నువ్వు 4 గ్రేటర్ దెన్ 2 అంటే 3 వస్తుంది మేడం. 10 గ్రేటర్ దెన్ 2 అంటే ఏమొస్తుంది? ఇన్ బిట్వీన్ లో 10 3 మధ్యలో ఉన్న వస్తుంది. కాకపోతే ఏంటంటే ఇప్పుడు 3 గ్రేటర్ దెన్ 2 అన్నాను. 3 గ్రేటర్ దెన్ 2 అన్నప్పుడు మధ్యలో ఏమొస్తాయి? కంప్లీట్ గా అంటే రేషనల్ నెంబర్స్ వస్తాయి అక్కడ. ఓకేనా? రేషనల్ నెంబర్ అందుకే తీసుకున్నారు. రేషనల్ నెంబర్ క్లియర్ పర్టికులర్లీ ఇయర్ మెన్షన్. ఓకేనా? This is equal to, we can write union of n equal to 1 x belongs to E f of x greater than Rn intersection x belongs to E g of x greater than alpha minus Rn. ఇక్కడ ఏం రాస్తారంటే జనరల్ గా వాడు ఏం రాసిండు? జస్ట్ వెయిట్. ఇక్కడ f of x రఫ్ గా రాసుకోండి మేడం. రఫ్ గా f of x greater than Rn greater than alpha minus gx. నెక్స్ట్ ఇక్కడ పాసిబిలిటీ ఏంటి? ఇక్కడ f of x greater than Rn ఒకటి వస్తుంది. Rn greater than alpha minus gx, g of x వస్తుంది. రాయండి f of x, which implies f of x greater than Rn and Rn greater than alpha minus gx.
Alpha minus gx.
అంతే కదా, సేమ్ 2 parts డివైడ్ చేస్తుంది.
ఓకే సార్.
2 parts డివైడ్ చేసినప్పుడు ఈ g of x ని ఇటు సైడ్ తీసుకురండి, లెఫ్ట్ సైడ్. Rn ని రైట్ సైడ్ తీసుకెళ్ళండి. therefore g of x greater than alpha minus Rn వస్తుంది. అంతే కదా?
Yes sir.
ఓకేనా? This one and here satisfying 2 conditions. You are divided into the what is that f of x greater than Rn greater than alpha minus gx, which implies both this one and f of x greater than Rn and g of x greater than alpha minus Rn. And then time was some union of this one only. So therefore union of x belongs to f of x greater than Rn intersection x belongs to g of x greater than alpha minus Rn. Therefore you can write clearly. X belongs to E f of x greater than Rn and x belongs to E the set greater than Rn and x belongs to E g of x greater than alpha minus Rn are measurable sets. Which implies their intersection is also measurable set. అంటే ఇక్కడ ఇంటర్సెక్షన్ ఇన్సైడ్ ఇంటర్సెక్షన్ చూడండి.
సార్ స్క్రీన్ పైన చేయండి సార్.
స్క్రీన్ పైన లేదండి. బుక్ పైన ఉందా? బుక్ లో ఉందా? బుక్ ఉంది కదా మీ దగ్గర?
ఉంది సార్. బట్ డైరెక్ట్ ఉంది కదా సార్.
అది అందుకే డైరెక్ట్ కాబట్టి నేను ఏమని చెప్పా? సో యూనియన్ ఆఫ్ x belongs to f of x greater than Rn greater than alpha minus g of x కదా. సో సైడ్ కి అక్కడ ఏం రాస్తారు? x belongs f of x greater than Rn greater than alpha minus g of x, which implies f of x greater than Rn and Rn greater than alpha minus gx. Then modification name was g of, which implies g of x greater than alpha minus Rn. So therefore we can write union of. అదే సేమ్ రాయండి 37 పేజీలో లాస్ట్ ఏముందో అదే రాయండి. రాసిన తర్వాత రాసారా?
Yes, sir.
రాసిన తర్వాత ఫస్ట్ ఉన్నది కదా, ఫస్ట్ వన్ x belongs to f of x greater than Rn and x belongs to g of x greater than alpha minus n, alpha minus Rn are measurable sets. Then
Two sets. Okay, sir.
measurable sets. Then their intersection is also measurable set. Measurable set. Measurable set. That is clear. That is 37 pages లో ఇక్కడ బ్రాకెట్ ఉంది కదా, ఈ బ్రాకెట్ లోపల ఉన్నది మొత్తం ఈజ్ మెజరబుల్ సెట్ అని రాయండి. ఎక్స్ బిలాంగ్స్ టు యూనియన్ రాయకండి, యూనియన్ రాయకండి. ఎక్స్ బిలాంగ్స్ టు ఎఫ్ ఆఫ్ ఎక్స్ గ్రేటర్ దెన్ ఆర్ఎన్ ఇంటర్సెక్షన్ ఎక్స్ బిలాంగ్స్ టు డి ఆఫ్ ఎక్స్ గ్రేటర్ దెన్ ఆల్ఫా మైనస్ ఆర్ఎన్ ఈజ్ ఏ మెజరబుల్ సెట్. Measurable set. Measurable set. Measurable set. Measurable set. కింద మీకు తెలుసు కదా, arbitrary union of measurable set is a measurable. Write down. We know that arbitrary union of measurable sets is a measurable. Okay na?
Okay, sir.
Therefore ఇప్పుడు ఈ లాస్ట్ మొత్తం రాయండి. లాస్ట్ ఈక్వేషన్ యూనియన్ ఆఫ్ n equal to 1 to infinite ఆఫ్ మొత్తం is also a measurable set. Therefore union of n equal to 1 to infinity x belongs to such that of f of x greater than Rn intersection x belongs to is also a measurable set. Measurable set. Measurable set. ఇక్కడ పైన మనం ఒకటి తీసుకున్నాం చూడండి, పైన ఏం తీసుకున్నాము, నౌ ఫర్ ఎనీ ఆల్ఫా బిలాంగ్స్ టు ఆర్ తీసుకున్నాం చూడండి మేడం. ఎక్స్ బిలాంగ్స్ టు ఎఫ్ ఆఫ్ ఎక్స్ ప్లస్ ఎఫ్ ఆఫ్ ఎక్స్ ఎఫ్ ప్లస్ జీ ఆఫ్ ఎక్స్ గ్రేటర్ దెన్ ఆల్ఫా ఈక్వల్ రాసామా, అది ఈక్వేషన్ 1 పెట్టుకోండి.
Okay, sir.
Equation 1. From the equation 1, ఇప్పుడు ఏం రాస్తారు 38 పేజెస్ లో ఫస్ట్ ది ఫ్రమ్ ద ఈక్వేషన్ 1
It belongs to E.
సేమ్ టోటల్ రాసేయండి.
First line. Okay, sir.
అదే ఎక్స్ సేమ్ అదే వస్తుంది మనకి. Is f plus g of x greater than alpha is equals to is a measurable set.
Okay, sir.
Right. Is a measurable set. Hence, and meaning in measurable set ante hence f plus g is a measurable function. Measurable function. Clear?
Yes, sir.
అంటే ఇప్పుడు ఏం అంటే ఇక్కడ నెక్స్ట్ కేసులో నెక్స్ట్ నవ్ ప్రూవ్ దట్ ఎఫ్ మైనస్ జీ ప్రూవ్ చేయాలిగా మనం.
Yes, sir.
ఎఫ్ మైనస్ జీకి ఒక సబ్జెక్ట్ ఎఫ్ ఈజ్ ఏ మెజరబుల్ ఫంక్షన్. రైట్, ఆల్రెడీ ప్రూవ్డ్ దిస్ వన్. లెట్ ఎఫ్ ఈజ్ ఏ మెజరబుల్ ఫంక్షన్, లేకపోతే ఎఫ్ కామా జీ ఆర్ మెజరబుల్ ఫంక్షన్స్. ఎఫ్ కామా జీ ఆర్ మెజరబుల్ ఫంక్షన్స్ ఆన్ ఈ. On E. On E.
Okay, sir.
For any constant C. For any C. For any C. C into G is a measurable function. తెలుసు కదా, ఆల్రెడీ ప్రూవ్డ్.
Yes, sir. Yes, sir.
బ్రాకెట్ లో రాయండి అక్కడ, ఆల్రెడీ దిస్ ఇస్ ప్రూవ్డ్.
Okay, sir.
Therefore f comma C into G are measurable functions. F comma C into G are measurable functions. Then their addition. అంతే కదా. Then their addition F plus C into G is also a measurable function. F plus G into C into G is also a measurable function. అంటే అక్కడ మనకి for any C is measurable అన్నాడు. Particularly C equal to -1 తీసేసుకోండి. క్లియరా?
Okay, sir.
Particularly C equal to -1. C equal to -1. అంటే for any C అని చెప్పేసిన. For any value C is a real number. Particularly C equal to -1. Hence F minus G is a measurable function. అంతే. F minus G is a measurable function.
Okay, sir.
ఓకేనా? నెక్స్ట్ ఎఫ్ స్క్వేర్ చేయండి ఫస్ట్. ఎఫ్ స్క్వేర్ ఈ సెట్ ఉంది కదా, ఈ సెట్ రాయండి మీరు. ఎక్స్ బిలాంగ్స్ టు ఎఫ్ స్క్వేర్ ఎక్స్ గ్రేటర్ దెన్ ఆల్ఫా greater than alpha if alpha less than 0 is equals to E. Alpha less than 0. Alpha less than 0 అంటే ఇక్కడ ఆల్ఫా లెస్ దెన్ 0 అంటే మేడం అబ్జర్వ్ చేయండి, ఎఫ్ స్క్వేర్ అంటే ఆల్వేస్ పాజిటివ్ అవుతుంది. ఓకేనా?
All terms becomes
సేమ్ x belongs to E such that f of x greater than alpha root alpha అంటే మీనింగ్ ఏంటంటే ఇక్కడ now we prove that f square x greater than alpha is a measurable set means f of x ఏమైతుంది greater than previous one f of x plus c greater than alpha and f of x greater than c minus alpha and f of x c into f of x అంటే alpha by c అయింది. అక్కడ c అనేది ఏమైంది, అక్కడ పాజిటివ్ నెగిటివ్ 0 అయింది. ఇక్కడ ఎఫ్ స్క్వేర్ అంటే ఏమవుతుంది గ్రేటర్ దెన్ రూట్ ఆల్ఫా అవుతుంది. అర్థమైందా? రూట్ ఆల్ఫా అంటే ఎఫ్ స్క్వేర్ అంటే ఏ స్క్వేర్ మైనస్ బి స్క్వేర్ అంటే ఏమొస్తుంది మేడం, ఏ మైనస్ బి ఏ ప్లస్ బి వస్తుంది. ఇక్కడ కూడా సేమ్ ఈ ఆల్ఫా లెస్ దెన్ 0 ఓకే ఎక్స్ బిలాంగ్స్ టు ఎఫ్ ఆఫ్ ఎక్స్ గ్రేటర్ దెన్ రూట్ ఆల్ఫా అండ్ ఎఫ్ ఆఫ్ ఎక్స్ లెస్ దెన్ minus root alpha if alpha greater than or equal to 0. Okay, అది ఒకటి రాయండి.
Okay, sir.
And observe that for any value alpha belongs to R. అంటే లెస్ దెన్ కావచ్చు ఆల్ఫా బిలాంగ్స్ టు ఆర్ మీన్స్ అది నెగిటివ్ ఆర్ పాజిటివ్ ఆర్ 0 3 కేసెస్ ఉంటాయి. ఆల్ఫా బిలాంగ్స్ టు ఆర్ మీన్స్ డిఫరెంట్ కేసెస్ అంటే పాజిటివ్ అవ్వచ్చు 0 అండ్ 0. అబ్జర్వ్ దట్ ఈ కామా ఎక్స్ బిలాంగ్స్ టు ఈ రెండు సెట్ రాయండి మేడం. x belongs to E such that f of x greater than root alpha and x belongs to E f of x less than minus root alpha are measurable sets. Which implies x belongs to E f square greater than alpha is a measurable set. అంతే కదా?
Yes, sir.
X belongs to f square of x greater than alpha is a measurable set. Therefore, finally, f square is a measurable function.
Measure. Yes, sir.
F square is a measurable function. ఓకేనా?
Okay, sir.
ఇక్కడ ఏం రాస్తామంటే నెక్స్ట్ ఫైనల్ ఎఫ్ ఇంటూ జీ ఉన్నది కదా,
Yes, sir. Conclusion.
ఎఫ్ ఇంటూ జీ కూడా రాయాలి కదా. దీనికి ఏం రాస్తారంటే రాయండి. we know that f comma g are measurable sets if f comma g are measurable sets
If
if f comma g are measurable then f plus g and f minus g, f plus g and f minus g are also measurable. Already proved కదా ఇది.
yes, sir.
Next then f plus g whole square and f minus g whole square are also measurable. అంటే f square already prove చేసినాం కదా.
Yes, sir.
Any measurable function f is measurable, then f square is also measurable. F plus g is a new function h equals to, that is also measurable function. Its square is also measurable function. Right down. F plus g whole square and
F plus
f
g whole
plus g
square, F minus g whole
the
square.
whole square are measurable functions. ఇక్కడ ఏం రాస్తారు? f plus g whole square minus f minus g whole square ఏమైతే చెప్పండి?
F plus g
whole square minus f minus g whole square ఏమైతే చెప్పండి?
measurable functions.
No. Only a plus b whole square minus a minus b whole square. And
F square, F square minus
4ab అవుతుంది. ఇక్కడ ఉన్నది రాయకండి, ఇది కూడా తీసుకోవచ్చు.
acha.
4ab అవుతుందా?
Yes, sir.
అంటే అక్కడ ఏం రాస్తారంటే
Hello. Hello, sir.